We'll be back after the short break. So we are still under applied mathematics. The theme is mechanics. And then the topics which we are still under components and resultant of forces. So in previous lesson, we were looking out the sort of components of a force or of two or more forces acting on a particle or at the point. We say we consider the two forces P and Q acting on the body as shown, which was P was acting at an angle star and then Q was acting at an angle alpha. Then we said when you are resolving those forces, you first consider one particle by one. Then we considered force P. We considered force P. Then after considering force P, we got to the resultant or the vertical component of force P. We said when you are calculating the vertical component, you just get that force times the sine of that angle. We have been mentioning it since the previous lessons. So it is that force times the sine of that angle. So since our force is P, so our vertical component of force P will be P times the sine of the angle for P, which is star. So it will be P times the sine star. Then the horizontal component, we use cos of that angle. It will be Px, which equals to the force P times the cos star. So after getting Px and the cos P, these are the two components of force P, which is vertical and horizontal. Then we are going to consider now the second force, which is force Q. We said also force Q has two components. But when you are getting components of force Q, you use its angle, not the angle for P. So don't be mistaken to use the same angle. And we say you first look at the direction of the force. If the force is slanting downward, then its vertical component will be downward. Then for horizontal components, it will take the direction where it is going. Now for example, P is going to the right. So implying its horizontal component will also be to the right. So then we said, now we are going to calculate the vertical component of Q. So vertical component of Q is given by that force Q times the sine of the angle. Now here it is sine alpha. Why? Because the angle between Q and horizontal is alpha. So this is Q times this sine alpha. Then the horizontal component is Qx times Qx equals to Q cos alpha. The horizontal component we say we use cos. So this one brings us to what we need to cover today. Now in our today's lesson, from previous example or from previous derivation, we have finished deriving the components of force P and Q. But we have not yet finished resolving those forces. We are supposed to resolve to get the components and then resolve their components. Now, if this one was the original force acting on P, after getting the vertical and horizontal components, now we have two different setup. Then we are supposed to redraw our diagram. These diagrams must be in straight line. If this one is our body or particle, we have force P, which is having the vertical component, which is acting upwards. So this component Py is acting upwards, and then there is component Px. And then for Q, there is also component P. There is component which is acting vertically downwards, which is Qx, and this one is going in this direction, which is Qx. This one is Qx, this one Qy. This one is Py, this one is Px. So that's the final setup. Now, before coming to components of forces, we looked at what we call resolving the forces which are acting on a particle perpendicular and horizontal. We say if you have two forces in the same direction, you add. If you have two forces in different direction, you subtract, but provided they are acting perpendicular to each other. So here we are going to get what we are calling the resultant horizontal force. Now, the combined horizontal force or the combined horizontal component of force, P and Q. Then horizontal components of P, Px and Qx is given by, let us call it Fy. Let's call the horizontal components of P and X as Px. Since they are forces, let us call it as force Fx, which equals 2. Now here we have the components of force. We said when forces are in the same direction, we add. To get the horizontal component or the final components, we add them. Since P and Q are in the same direction, we shall add. That is our Px plus Qx. But we say the Px is given by P, then we feed in the values of this component. Our Px equals to, what is our Px? Px is given by P cos star. And then what is our Qx? Our Qx is given by Q cos alpha. This is our components or the resultant horizontal component of Px and Qy. We said it is P, since they are in the same direction, it is Px plus Py. But we say our Px is P cos and our Py is, our Qx is Q cos. So we substitute those values of Px and Qx. So we come to vertical components. So that the resultant vertical components of P, X and Q, X. Resultant vertical component of Px and Qx. We said if there are two forces acting at the same point but in different direction, we subtract. We get the bigger one minus the small one, and then we note the direction. So for our case, let us take Py as the big one. So how are we going to calculate the vertical component? Let us call it as Fy. So our Fy will be given by Py plus Qy. So we say our Py is given by P sin star plus Qy is given by Q sin alpha. So we get another setup. Now we have gotten the resultant vertical components, and then we have gotten the resultant horizontal components. So how do we calculate the resultant force? Now that's our next question. How do we calculate the resultant force? How do we calculate the resultant force? Now from the above setup, this is our now forces acting on the particle. This is our particle. We have the vertical component. Vertical component, we said it is Fy, and then the horizontal component we have said it is Fx. So the resultant component between these two forces, it is acting at a given angle. Let this angle be angle what? Angle beta. Let that angle be angle beta. Then this way are the resultant components acts. That's where the resultant component of force Fy and Fy is acting. The resultant component capital F is acting in this direction. So that's the resultant components. So if you extrapolate this, if you extrapolate the vertical component, which is this one going up is the same as for force Fy, and then this one for down is for force Fx. This one coming in this direction is for force Fx. From your identities of the angle, say if you have two sides A and B, if you have an angle of angle A of side A and B and C, how do you get the angle C? We say that from the theorem you have our C squared equals to A squared plus B squared. That one in O level. So how do you get our C? Our C become A squared plus B squared under square root. So now this is the identity we are going to use to calculate the force. The force is on C. Our f of x is on B. Our f of y is on A. So our resultant force F. Our resultant force F is given by, so it will be F squared plus our Fy squared plus our Fx squared. So the resultant F is given by our square root of Fy squared plus F of x squared. So this one become our resultant force F of the two particles moving in different direction. This is our resultant force F. Two particles moving in different direction at different angles. This is our resultant force F. And that's how we shall be calculating resultant force F. Someone may be wondering what is Fy. We have shown how we are coming with Fy, and we have shown how we are coming with Fx. So after being given the value of P and Y, the value of P and X, you can get our Fx from substituting the value of P and their angles is the one you put here, and then our value of Fy, you also substitute and get it. But we said the force is a vector quantity. So we shall calculate the angle at which it is acting. So what is the angle at which this force is acting? That's the first question. What is the angle at which this force is acting? So we say from the angle, we say we have opposite, we have adjacent. So when we are calculating the angle, we use tan star or our angle is beta. Our resultant force is acting at beta. Tan beta is given by opposite. What is the opposite of tan beta? This one. Adjacent is this one. So it will be opposite out of adjacent. So our tan star is given by opposite out of adjacent. And our tan beta is given by opposite, which is Fy, out of Fx. So our beta is got by tan arc. It is tan arc of the resultant here after dividing Fx out of Fx. So this one become our angle in degree. So this is the resultant force and this one is the angle. So we are going to meet in the next section when we are going to see how to apply this example. Thank you for watching.